Okay. We're going to have to be able to calculate concentrations. And the first unit of concentration and the primary unit of concentration is what we call molarity. Right? The symbol for molarity is a capital M. So, molarity is defined as the ratio of moles of solutes, right? So the moles of the solute divided by the liters of the solution. So, as long as you know both, you can calculate molarity. Now, when we say solution, we want to point out that it's total volume of solution, okay? And it has to be specifically in liters. So that means if you are told the volume in milliliters, you will have to convert it first, okay? All right, solution volume varies somewhat with temperature. And so therefore, the molarity can be subject to change if the temperature is changing a lot, right? So molarity is very useful when you're talking about places that are a relatively stable temperature, like indoors, like in a chemistry lab. But when conditions change severely, then molarity is not the best concentration to use. Then we have other concentrations for that, right? But seeing as how every lab that we're going to be doing is we're going to be doing indoors here, it's fine. Okay? Okay, so you might have seen or heard me say molar before to describe molarity. Like on some of the bottles of solutions we've used earlier in the year, if it said 3M, that's read as 3 molar. We've used something like 6M, and that's 6 molar. Okay, so the capital M just means molar, right? It's in reference to molarity. So, given that this is a 3-variable equation, right, like all equations, right, in this class, like all equations, I'll give you the base equation. This is the one you'll get, but be aware that we need to be able to manipulate this. We need to be able to solve for the other variables, specifically the moles and the volume. So, if molarity is equal to moles over liters, oftentimes we're going to need to be able to find the moles, which means molarity times liters is how we find moles. Right? Multiply both sides by the volume, and that's how we isolate moles and solve for it. We also need to be able to find the volume. So if we need to find the volume, then your multiply both sides by liters, divide both sides by molarity, and then you end up with liters is found by taking the moles divided by the molarity. So, depending on what the question needs, just be prepared to rearrange it. Right? This is nothing new. We've done this ever since we started working with density. Okay. So let's try this first problem here. If 1.461 grams of sodium chloride is dissolved in water and made up to 250 milliliters of solution, so this is our volume, what is the molarity of the solution? Okay, so generally, it's easiest if you start by writing the equation and rearranging it for what you're looking for. In this case, they're asking for molarity, so we just take the base equation and we just make sure that we have both of those variables in their right units. So they gave me the amount of solute, but they gave it to me in grams. So 1.461 grams of NaCl. We have to convert that to moles first. Mole of NaCl. The molar mass is 58.44 grams. Which is 0.0250 moles. Okay, so I've got the moles. And I need volume. So they gave me 250 milliliters. 250 milliliters has to be converted to liters. There's 1,000 milliliters in a liter, so this is 0.0250 liters. So now we can just simply calculate the molarity. Oops, you know what? I just realized I made a mistake. It's not 0.025. It's 0.25. So therefore, our molarity is going to be 0.10 molar. I can have 2 sig figs because the 2 sig figs in my original volume measurement. Okay, so this is your basic molarity calculation. You have to calculate moles, you have to turn your volume into liters, and then you divide, you take the ratio. Now the unit can be written as capital M, or it can be written as 0.10 moles per liter. They both mean the same thing. They're both fine. Okay. So let's do another one. What is the molarity of a calcium chloride solution where 100 grams are dissolved in 100 milliliters of solution? Okay. So again, we're trying to find molarity, so we need to find moles first. So they told us we had 100 grams of calcium chloride. Now, where people can very easily go wrong is that they might forget what the charges are and write the formula incorrectly. Calcium is a +2, chloride is a -1, so it's got to be CaCl2. If you write the formula incorrectly, you're going to get the wrong molar mass, which means you're going to get the wrong moles, which means you'll get the wrong molarity, right? So just check your units when you write your formula. Okay, the molar mass of calcium chloride is 110.98. So we have 0.90106 moles of CaCl2, and they told us that the volume of the solution is 100 milliliters. 100 milliliters is 0.1 liter. Therefore, the molarity 0.90106 moles over 0.1000 liters. We're going to be allowed to keep 4 sig figs, so we'll call it 9.011. How are we doing so far? Okay. All right. So here we are given the volume of the solution is 500 milliliters. Let's make this 500 with a decimal point just so we have 3 sig figs instead of 1. And they tell us the molarity. How many grams of sodium phosphate are dissolved? Okay, so in our formula for molarity, grams is not present, but moles is. So that means we're going to solve for moles first and then turn it into grams. Okay, so if molarity is moles per liter, to find moles, you're going to take molarity times liters. That's going to be the first thing you do, and then you will turn that into grams. So 3.2, and this time I'm going to write the units as moles per liter, and I'm doing this deliberately so that you can see the liters cancel. Right, 500 milliliters is 0.5 liters. So 1.6 moles. And sodium phosphate is Na3PO4. The question was asking for grams, so we need the molar mass of this. So 22.98 times 3 plus 30.97 plus 64. That's not right. Let me do that again. 163.91 grams per mole. So 262.256. We're only going to be allowed to keep 2 sig figs, so we'll call it 260 grams. How are these sig fig rules? Are these coming back to you? Really, most of the times what we're doing is multiplying and dividing, right? Which means we're looking for the fewest sig figs, and that's how many we can keep. Okay. So, are you able to work your way around the molarity equation? Finding either moles, molarity, or volume. Okay. All right. So, the second type of concentration that we're going to calculate is mass percent. Now, there is a formula for this, but there doesn't really need to be a formula for this because you know that when you take the percentage of anything, it's always part over the whole. And that's what this is, okay? So the tricky part is when they're not asking for a mass percent, when they give you something other than the mass percent, or when they're asking for something else. So like here in this problem, how many grams of sugar are there in 550 grams of a 3% sugar solution? Okay, so let's think about what they're giving us here. They're telling us what the mass percent is so that we know this. They're also telling us that there's 550 grams of solution, so we know the mass of the solution. So really the question is asking, what's the mass of the solute? Grams of sugar, that's the mass of the solute. So let's start with what we know. The mass percent is 3.0. The numerator is unknown, but the total mass on the denominator is known. Okay, so we need to solve for the mass. Now at this point we follow order of operations because we only have one missing variable, so we divide both sides by 100. 0.03 is equal to the mass divided by 550, and the times 100 was divided out, so really it's just a matter of now solving for the mass. So 0.03 times 550. So 16.5 grams of sugar. So does that make sense how we set this up? Let's try the next one. Hydrochloric acid is 37% by mass. Okay, so 37% by mass. If 7.4 grams of HCl are needed, what is the mass of solution? So they're asking for the total mass of a solution. So that means 37% is equal to 7.4 grams of HCl. Well, that's the numerator. So this is our setup. Okay, again, let's cancel the percent sign, so let's divide both sides by 100. So that means we have 20 grams of solution. Again, remember the solution is both parts. The solution is the solute plus the solvent. That's the total mass. So, I didn't even give you a problem where I asked you to find mass percent. So let's do that. I'm going to find some space and give you an example. Okay, so let's say I have 2 moles of table sugar dissolved in 200 grams of water. Find the mass percent. Now, sugar's molar mass is 342.3 grams per mole. So that should save you some time. Okay, take a second. See if you can come up with the answer. Think about what you need for mass percent. You need mass of solute. You were not given mass, you were given moles. So what's the first thing you should do? Now here's the tricky part. The total mass of solution is not 200 grams. The mass of solution is the mass of the solute plus the mass of the solvent. Anybody have a solution? Jake? 77.39. Good. That's right. Let's go over that. So the first thing we need to do is we need to find our mass of solute. So 2 moles. The molar mass was given to you as 342.3 grams per mole. Okay, so finding our solute mass is 684.6 grams of sugar. Okay. And then the mass of the solution, well, the solution has to be the solute plus the solvent by definition, right? So that means you're going to take the 684 plus the 200. So our mass percent will look like this. And that's what gives us our 77.4% weight by mass. So this is actually pretty close to a concentration of syrup, for example, maple syrup. So do you guys know anything about maple syrup, how it's made? Have you ever gone to Spring Valley in Schaumburg and seen the tree tapping exhibit where they collect the sap and they boil it down? No? So what they do, when they actually tap the trees, the sap looks really liquidy, right? Like a thick liquid, okay? And then they collect these giant barrels of it and they boil it. So when you boil anything, what happens? What changes about something if you boil it? Does anything come? Anything go? What happens? The water leaves. The water evaporates. Is water the solute or solvent? It's definitely a solution. Is which part is water? In syrup. So whatever there's more of is the solvent. Water is the solvent. So we take this big, barrel, and it's boiling. And so there's water leaving, and there's water leaving until much of the water has gone. And so what you're left with is a highly concentrated sugar solution, which at that point becomes something that you recognize as syrup. Right? And it gets thicker and thicker and thicker. The reason why it pours so slowly is because sugar molecules have lots of hydrogen bonding. So the molecules attract each other really strongly, and so they're resisting moving, right? Anyways, just a practical application. All right, let's talk about an example that we would see from lab. So let's say in lab we have an evaporating dish. The dish by itself has a mass of 25.2 grams. Okay, so it's weighed by itself. And then we add 10 milliliters of barium chloride solution. We add it to it again, and then it's weighed again. The weight goes up. Makes sense, right? You're adding something to it, so the weight should go up. And then we heat it. So there's our solution in there, 10 milliliters of solution in there. And then we heat it, and anytime you heat a solution, it's the water that evaporates, but the solute usually stays. And then it's weighed again. The final mass is 26.95 grams. So first, we need to understand what happened. We took a dish, we poured some liquid in it, we heated it, the liquid went away, and now there's a bunch of solids left in the dish. That solids left over, that's your solute. The solute was BaCl2, barium chloride. So we have a bunch of questions we can answer. First, what's the density of the solution? Let's back up. Density. Density is mass divided by volume. Remember that? So for the solution, we need to find two things. We need to know how much the solution weighed and what the volume of the solution was, which isn't hard because that was given to us. So volume is here. But how do we find the mass of the solution? I know how much the dish weighed. Yeah, let's just subtract. Which numbers do I subtract? Because I see a bunch of numbers up there. 25.2 and 36.6. Okay, yep. 36.63 grams is the dish plus the solution, minus 25.20 grams is the dish. So after that subtraction, that's going to give us just the solution by itself. .43 grams of solution. By the way, when I write SOLN, SOLN is shorthand for solution. Okay, so I know the mass of the solution and I know the density. I know the volume, right? So this is this. So now we can go ahead and plug them in. The density of the solution is 11.43 grams per 10 milliliters. So in other words, 1.143 grams per milliliter. How come the density of a solution is greater than the density of water? The density of water is 1 gram per milliliter. Why is this more? Why do you weigh more when you step on a scale while you're holding your cat? There's more stuff there, right? The solution contains solute and solvent, whereas water is just a solvent. So solutions will generally have densities greater than water. Okay, let's find the molarity. In order to find molarity, you need the moles of the solute and you need the liters of the solution. Okay, so what can we find? I don't have moles anywhere, but I do have numbers that will allow me to get moles. How can I do that? How can I find the mass that eventually will lead me to moles of solute? So don't I know the mass of the dish and the dried solid? And I know the mass of just the dish by itself. So 26.95 grams is the dish plus the solid minus 25.2 grams just the dish. So 1.75 grams BaCl2. Okay, that's my solute. We're almost there. What do I do next? Hannah, what do I do next? Or what's one thing I can do to find the moles, right? To get here. Yeah, let's turn our grams into moles, right? We have the moles, we have the grams now. So the molar mass of barium chloride, let's see, 137.3 plus 2 times 35.45. So it's 208.2 grams per mole. So that means we have 0.008405 moles of BaCl2. Okay, and then my volume of solution. I do know the volume of solution, don't I? Didn't we use it earlier? What's the volume of the solution? The heck, what's my volume? 10 milliliters, but I can't use milliliters. Yeah, divide to get into liters. 0.01, right. So molarity will be 0.008405 moles divided by 0.01000 liters. So 0.841 molar. And the last thing is to find the mass percent. So I need the mass of the solute and I need the total mass of the solution. And I think both numbers are on there already. What's my mass of solute? From the screen. Will I see that again? 1.75 grams of the barium chloride solute divided by, what is my mass of solution? Also on the screen. It's a lot on there, but it's somewhere in there. Might even be highlighted. 11.43 is the mass of the total solution. Therefore, 1.75 divided by 11.43 times 100. We're looking at a 15.3% solution by mass. Okay. Calculations for concentrations. The math itself, the individual steps. Really, what did we do? We just did a bunch of subtractions and we did a bunch of divisions, right? So the math is not the hard part. The hard part is figuring out what number to use and in what order to line the steps up, okay? So you have to think big picture. You really need to know the definitions of the concentrations. Molarity, you have to know the moles, you have to know the volume in liters. Mass percent, you need to know the mass of the solute, you need to know the total mass of the solution. And this, of course, is something that's just going to get easier with time, right? The more of these you do, the more practice you do, the easier it'll get. So let's add a page, and I'll just give you another problem, and we'll see how we do on it. I totally put that in the wrong place, but that's okay. All right. Oh, you know what? Here, let's just do this for now. Find the molarity. Anybody get a value for the molarity? Yeah, Sam?
1.34.
That's right. So let's go over this. We started with 25 grams of KCl. So need this in moles. So the first thing we do is can add up and find the molar mass and then divide. So the molar mass is 74.54 grams per mole, right? Which means 0.3354 moles. And we had 250 milliliters, but like we said before, we can't use milliliters. The definition, it has to be in liters, so 0.25 liters. So 0.3354 moles over your 0.25 liters. Looks like technically I only gave you 2 sig figs here. So 1.3 molar. Okay. Molarity is our primary unit of concentration. We will be solving for that the most, but you still need to know how to work with mass percent. There are other units of concentration, but they're kind of outside the scope of what we need to do in this class. So